Okay, that should be good to go. So let's have a look at how to generate a block thickness when you don't have a block thickness or a thickness built in already into your model. So this one's just come up in support. I figured I'd do a video on it. The first thing you're going to need to do is make sure you've got both roof and floor centroids. You've generally got floor centroids if you've done haulage or some other things, but you're also going to want roof centroids. So I'm going to add in my roof centroid field for both waste and coal in this model. I'm going to move them above each other so it's a little easier to see what's going on. Apply that and then run the centroid calculator. So if they're named nicely, they should get mapped for you, but if not, manually map them. We're going to run that centroid calculator. And the next thing we need to do is create some calculated fields for roof and floor Z. So we've got these already calculated, but let's create a folder for thickness, keep it separate. And I'm going to start with a roof Z. Now this formula looks a little complicated. It's just the easiest way to make sure that the answers that you're going to get are consistent. So the first thing we need to do is make sure that if there's a waste centroid, we'll try that one first, and if there's a coal one, we'll try that one. So we're going to start with the roof centroid. Apologies, you're not going to quite see this. I might just change the layout of my window a little bit so you can see it. There we go. So we're going to look for the get Z coordinate of the roof centroid. And what we're trying to do here is we need to make sure that if this is 0, you'll get a 0 from this if there's no centroid. So if you don't have a solid, this will return a 0. So what you want to do is basically change this so that if there's no centroid, that you get a different number. So what we're going to do here is put in an is null. So an is null is a check to make sure that it's there. So if it's null, if it's empty, we want a very small number, as in we want a very low number. We don't want to return 0 because we want to avoid that. 0 might be higher than your roof if you're in a negative RL situation. So that firstly gives us just the waste centroid. We want to basically do the same thing for the coal centroid. And the reason why we want to do that is because it's possible, not likely, but possible, that our solids are inverted for a given record. So I'm going to replace the word waste with coal. And now I've got two components here. And what I want to do is I want to grab the maximum of those two. Whichever one of those two is the higher. So I'm just going to go max. And I'll put this formula in the description of the video when I'm finished. So we've got the maximum of these two numbers. So the maximum of that number and of this number. So a little bit verbose, looks a bit tricky, but basically just says if it exists, if it doesn't exist, give it a low number. If it does exist, give its regular number. And we're going to do that one more time for the floor Z, but we're going to make a slight change to this. And rather than looking at the maximum, we're looking at the minimum. So we're looking at the lowest possible number. And we're going to switch our change to be a high number because that's going to mean that there's nothing there. And we're going to change our roof centroid to be relating to floor centroid. If you go Control-Shift-H in here, you can replace the word roof with floor, hit enter a few times, and that will replace it for you. Okay, one more change. We're going to run, when we look at the aggregation, we're going to use the maximum for roof and the minimum for floor. Now, it's possible that you have a record that has neither a roof or a coal centroid field. We're going to handle that in a minute as well. So we're going to click apply. We're going to hit apply here. And if we look into our database, you can see at the block level of this one that the highest roof is 140, the lowest floor is 33. And that means that if we subtract those two numbers at the block level, we're going to get the block thickness. So that's the next component of this. So we're going to create a calculated field for this. Now, look, ideally, you get these numbers from your actual like design package, reserving package, but you're not always in that situation where you're able to do so. So we'll create thickness. And the first thing we're going to do is we're going to check to see if either of these numbers are greater than, like, if either of these numbers are that 999 number, because if they are, we don't want to use them. So let's have a look at roof Z. So basically, there's an absolute value, as in the value of something without the negative in it. So if that value is greater than a given number that we're interested in, oops, sorry about that, take that off the screen. If that number is equal to 99999, then we're going to use 0. Because the thickness won't be able to be calculated. Something's wrong with the centroid, something's missing. We won't be able to actually use it. But if we do have it, what we're going to do is we're going to return the subtraction of those two numbers. So we're going to look at roof Z minus floor Z. Close that off. So we've got the if, the true, and then the false. Okay. So there is a possibility, however silly possible, that number is negative because the thicknesses were around the wrong way, like your centroids were calculated poorly. We're going to assume that that's incredibly unlikely. And then in terms of the aggregation, this is only happening now on a per record level, but what we want to do is actually make it happen on a block level. So we're actually going to use in the get value function. If you look at the get value function, you've got the option of picking your node. So what we're going to do is we're going to go up to the parent, that is the block level. So there's a get parent function where you can plug in the level, and that can come in after your field that you've selected. So we're going to put in get parent block, and that is the trick. So if that value, and we'll go with those two, and I just realized now that I'm doing it because I haven't actually done this for a long time, is we probably need to check the floor. At the block level. So if either of those are 99999, will give me 0. Otherwise, go to the block level, get me the roof, go to the block level and get me the floor. And the reason why that will work is because we have an aggregation of maximum and minimum. So what actually happens is we go to the block level in this calculation here, we go to the parent at the block level, and Spry understands that you're looking for the maximum. So plug that one in as well. And in this example, we'll just go with average, although it's not particularly important the way we're going to planning on using it. Okay, so you can see here we've got a difference of 108. The rounding gets a bit funny, but that is the difference between those two numbers there. So that's the calculated field that gives us that value, the difference between those two. And that will also give us the difference at any level. So it's not a 5 meter thickness at the block level. You see all of these share a 106 meter thickness for the block level. So we probably should call it block thickness. Okay, so the next thing you need to do is generate the custom field. This one's nice and easy. Custom field, create new custom field, block thickness. This is just going to look up the block thickness. You don't need to multiply it by source percentage completed. The plan is not to aggregate it, it's just to report it out once. So we're looking for the block thickness. there. And the aggregation for this is just going to be, we'll just average this based on source quantity. It doesn't really matter because the way you're planning on using it is in a pivot table. So rebuild our schedule results. No need to save for the moment. Let's create the pivot table that reports that out. So in the pivot table, we're going to grab the hit, strip, and the block thickness. And that's it. So we probably should make a couple of minor changes. In my model, I'm working in metric, so I'm going to change that to be formatted with a meter. You might want to add that. So you can see your block thickness. Now, that's the end. If you're happy to use it in a way that uses your reserved blocks, then you're done. What I'm going to do is I'm going to show you an alternative or an extension to this where you only use the blocks that have been scheduled. Because in this model here, you may have more reserves than you actually plan to schedule, and you want to return just the thickness of what you actually scheduled in your plan. So what we're going to do is, instead of using the calculated fields for the post-scheduled tasks, what we're going to use is, calculated fields for the reserve thickness, we're going to use post-scheduled tasks. So I'm going to create an entry. First thing I'll need to do is have somewhere to store that information. So I'll create a post-scheduled task folder. And I'll plug in a roof Z. Same setup as calculated. In fact, it might make sense to just steal that folder and untick the calculated components of that when reinventing the wheel. Okay, so roof, floor, and block thickness. In fact, we can keep that expression. We just need to replace calculated thickness with post-scheduled task thickness. So it's just schedule. But how we populate the roof and the floor Z is going to be using a post-scheduled task. So we're going to fill in the roof Z, and the value expression is going to be basically identical to what we did before. We're going to look up the centroid. In fact, I'm going to steal the formula because it's basically the same. Now, the concept of the calculated roof floor centroid is not quite the same in this. It's very similar though. So if we have a look at what that actually is, it just has the word source in front of it. So a source calculated roof centroid, because the case doesn't understand which table it should be looking at. So if we add source in there, that looks pretty good. We'll insert a copy to try stealing formula for the other one as well. Source, all of these again. Now it's complaining that we're not using the max, the min. So we should be, technically, it's not really something to worry about, but if you want to make sure that you actually grab more than one line of the schedule may have different values, and even though in this example it's not going to happen, you might want to wrap the entire function in a schedule max and a schedule min. I don't think it's logically possible in this example for it to make a difference, but it's good practice to be in to remember that you should be using schedule min, schedule max, or schedule sum, schedule weight average with your post schedule tasks. So if we rerun this, destination schedule is not relevant for this. If we rerun this, what we should see in our deposit table, if we scroll down, so missed something. I may just rerun my schedule. Let's just make sure I left a blank output schedule. Oh, I'm already actually noticing what it is that I was actually trying to demonstrate, which is that strip one doesn't actually get scheduled in this model. I've forgotten that. So that's already been pre-scheduled out. So no values are actually getting populated. If we just focus on this block here, where some of it's pre-scheduled and some of it is not, we'll pull that into the deposit table. 3. And let's just focus on the things that we're interested in, which is the roof, Z. Actually, thickness might help here. And floor Z. There we go. Oh, it's not also including previously selected. It's not behaving the way I thought it would. All right, let's try that one more time. Okay, so you can see here that I've got a roof Z and a floor Z that have ended up giving me slightly different results. So the floor Z here is not actually being populated. In this example, the 0 comes out to be a separate issue. You can tell I don't prepare these videos sometimes. So what we need to do is treat a 0 slightly differently. Basically, what we need to do here is add a very small number here. Because the default for these numbers is going to be, so we're actually asking for the minimum, but we actually need to make sure that there is a number, or there is a minimum of 0 is actually not an effective value to use. So we need to make sure that the centroid actually exists. So let's go with, what is the easiest way to do this? Oh, it's because I'm writing roof Z twice. That might help. We all make mistakes. All right, so that should otherwise have been fine. I was confused as to what I'd done wrong there. All right, so it's looking better already. Brilliant. Okay, let's run that. We run the schedule. And so in my original model with my fully reserved set, I'm running 158. In my adjusted version, I'm running 130. So it's just a way for you to be able to basically make sure that you are getting the appropriate reserved set of thicknesses instead of the regular set. So I'll leave it at that. If you have any questions about that, or you can't quite get it to work, as always, contact us, support@precisionmining.com. Otherwise, thanks for your attention and have a good one.